Today we're going to be graphing f of x equals ax squared. So remember, f of x is just function notation. F of x is equivalent to y equals, just in function notation. And we're going to be graphing x squared functions. So that means we're going to be looking at quadratics, which are U-shaped graphs, something new, a little different than what we've looked at. So we've looked at linear equations, which are lines. We've looked at exponential equations, which grow or decline quickly. And we've looked at absolute value graphs, which are a V-shaped graph. So now we're going to look at quadratics, which are a U-shaped graph. All right, as before, here are your standards. And to be successful, you need to be able to identify characteristics of quadratic functions and their graphs. You need to be able to graph a quadratic function of the form f of x equals ax squared. And you need to be able to compare the graph of f of x equals ax squared to the graph of the parent quadratic function f of x equals x squared. All right, as you can see, all the equations that we're going to talk about today have an x squared term. So if the largest degree is a 2, if the largest exponent is a 2 in your equation, then that means you are dealing with a quadratic function. So everything that we look at today is going to be of degree 2. All right, here's some vocabulary terms that you need to know. Make sure these are in your notes. A quadratic function is a nonlinear function that can be written in standard form, y equals ax squared plus bx plus c, where a is not 0. All right, that means it has to have the x squared to be quadratic. A parabola is a U-shaped graph of a quadratic function. So if we talk about a parabola, we're talking about the graph of a quadratic function, and it's always going to be a U-shaped graph, and it either turns up or down. It will never be side to side. If it's side to side, it would not pass the vertical line test, and it would not be a function. So remember, parabola is a U-shaped graph of a quadratic function. The vertex is the lowest point on a parabola that opens up, or the highest point on the parabola that opens down. So again, the vertex is that point, is kind of where it turns and goes the opposite direction, either the lowest or the highest point. The axis of symmetry, the vertical line that divides the parabola into two symmetric parts. So it's this line that goes down through the vertex so that your left side and your right side are symmetric. All right, make sure you know what the vertex is. Make sure you know what the axis of symmetry is as well. All right, key ideas. So we're going to talk about graphing ax squared, where a is greater than 0. That means it's always going to turn up. And if a is less than 0, meaning it's negative, if it's negative, it's going to reflect across the x-axis, and it will be an upside down U-shaped graph. All right, something to remember, the graph of y equals a times f of x is a vertical stretch or shrink by a factor of a of the graph of y equals f of x, where a is greater than 0 and a is not equal to 1. The graph of y equals negative f of x is a reflection in the x-axis of the graph y equals f of x. Again, that's just another way to say the same thing here that's in the key idea, just a little bit shorter. Example 1, identifying characteristics of a quadratic function. All right, so I went ahead and wrote a list of things out here. These are all things that we can find by simply looking at the graph of a quadratic function. All right, so the first thing is the vertex. Remember, the vertex is the turning point. So this point right here will be the vertex. So if we look, that's going to be -1, and that's down 4. So -1, -4 is the vertex. All right, the axis of symmetry goes right through the vertex. It goes through -1. So the axis of symmetry is going to be x equals -1. Then we can find the domain and range. The domain is all your x values. Since it goes to the left and to the right with arrows, that means it's going to be all real numbers. So you can write that as negative infinity to infinity. And then the range is everything above the vertex. The vertex is the lowest point. So the range is going to be all y values. Remember, the domain is your x values. The range is your y values. All y's greater than or equal to negative 4. So it's going to be y greater than or equal to negative 4. All right, then we also can determine where the function is decreasing and increasing. So we can see that it is decreasing when x is less than negative 1. So it is decreasing from the left side all the way down to negative 1. So you can see it's going downhill. If you trace it from left to right, it's going downhill for all values x less than negative 1. All right, and it's increasing from the vertex on. So it's going to be increasing. Again, you trace it from left to right. It's increasing from the vertex up. So it's going to be all values where x is greater than negative 1. All right, the y-intercept. All right, the y-axis is here. If you come down, the y-intercept is going to be 0, negative 3. Remember, the y-intercept is where it crosses the y-axis. All right, that means the x-intercepts are where it crosses the x-axis. So we've got negative 1, 2, 3. So negative 3, 0. And we've got another x-intercept at 1, 0. All right, we can also determine where the function is positive and negative. All right, so it's positive everywhere above the x-axis. So it's going to be positive everywhere below negative 3. So when I say below, I'm talking about my x's here. So when x is less than negative 3, it's above the x-axis, which means it's positive. So I'm going to say x less than negative 3. All right, and it's also positive on this side. It's above the x-axis on this side. So it's also positive when x is greater than 1. All right, let's just put an and there. All right, the function is negative anytime it's below the x-axis. So all these points between negative 3 and positive 1 is where the function is negative. So we can write that negative 3 x 1, and we can say everything between those points, the function is negative or below the x-axis. All right, the end behavior, what is the end behavior doing? All right, as x goes left, that means x is going to the negative infinity. What does y's do? It goes up, so it's going towards positive infinity. So we can write that as x approaches negative infinity. My y's, or f of x, same as y. My y approaches positive infinity because it's going up. All right, let's look at the end behavior on the other side. As x goes to the right, it's going positive. The x's are getting larger, always going positive to the right for x's. All right, as x goes positive, my y's are going up. So that means my y values are also going positive or towards infinity. All right, so there's a lot of information you can get by simply looking at the graph. So make sure that you can identify key characteristics by looking at a graph of a quadratic function. All right, your study tip, the points negative 1 and negative 4. So negative 1, negative 4, that's the vertex. 0, negative 3. -3, 0, and 1, 0 are solutions of the equation. This verifies that the vertex and intercepts are correct. All right, so when it says it's a solution of the equation, that means if you take the x's and y's and you plug it into this function here that's given, y equals x squared plus 2x minus 3, you get a true statement. Plug in the x value for your two x's here and plug in the y value here. And again, it should give you a true statement. So it's saying all four of these points are solutions. That shows that those points fall on that curve, and that verifies that the vertex and the intercepts are correct. All right, there's a self-assessment. It's the exact same thing. Identify characteristics of the quadratic function and its graph. So take a few minutes, pause the video, write down all the key characteristics from this graph, and we will check it shortly. All right, let's see how you did on the self-assessment. Identifying characteristics of the quadratic function and its graph. So it gives you the function y equals -0.8x squared minus 4x. We know it's quadratic because it has that x squared as your highest degree. So look at the function, look at the graph, and identify each part. So we found the vertex. The vertex is going to be about -2.5 and +5. The axis of symmetry goes right through the vertex, so it's going to be x equals -2.5. Your domain goes left and right infinitely with arrows, so -infinity to infinity. Your range is all your y values, so it's going to be everything below 5, so you write that as y less than or equal to 5. The function is decreasing after the vertex, so from the vertex on it's decreasing. So it's decreasing at all values greater than -2.5. The function is increasing or going up, so it's going up until you get to the vertex. So it's going up for all values of x less than -2.5. The y-intercept is where it crosses the y-axis. It's at 0, 0. The x-intercept is at -5, 0 and 0, 0. And the function is positive when it's above the x-axis. So it's positive for all values between -5 and 0, and that would be written like this. The function is negative when it's below the x-axis. So for all values less than -5 and greater than 0, the function is negative. The end behavior. So what does y do as x goes to the left? Okay, as x goes to the left, it's going towards -infinity, written like this, and it's going down. So the y values are going down. You can see the arrow going down. And then the end behavior on the other side, as x goes positive or to the right, it's going towards +infinity. The function is also going down. So your y values are decreasing, which means this side is also going towards -infinity. So this is pretty easy to do. Some people get hung up on how to do the end behavior. But if you do x less or x approaches, this arrow just means approaches. As x approaches -infinity and as x approaches infinity, we use the arrows to say approaching because there's an arrow here means it's going to keep going on and on and on and on. So these are always going to be the same because we're always looking at the left side and the right side, and we're going to look at whether it goes up or down on each side, and that's all you have to do for the end behavior. All right, that's all for this video. We will come back for example 2 in the next video.